Now we're going to talk a little bit about compaction. Towards the end, we're going to talk a little bit more of what Tommy mentioned as far as EPDs and what the federal government's looking at and what we're doing and different things. But what we're going to talk today about is compaction. We're going to talk about some compaction basics. What is compaction and why do we compact? We're going to talk about 4 elements of compaction, what they are, why we have them, how we use them. We'll talk about roller trains, how they can vary with different specifications and location. We'll talk about the different roller types, what we have, why we have them, where they can be used, and the advantages of each one. We'll talk about roller design specs, and this section here really is the principles of compaction. It applies to any roller, it doesn't matter what size, what manufacturer, what make it is. That's really the heart of the principles. We'll talk about some external factors that affect compaction, some things that we can control and some things that we can't control. We'll talk a little bit about the tech that's available and the sustainability that we're looking to do, especially just on the roller side, and then just kind of summarize everything from there. So why do we need compaction? Well, there's several things out there that we're doing. We're building dams, building pads, runways, and roads and streets. If I don't compact the dam correctly, people downstream are going to have a bad day. Building pads, if they're not compacted correctly, they're going to settle, we're going to have cracks, and we're going to have problems with that. Airport runways, I'm on one just about every week, so I want to make sure I land and fly out safely. Roads and streets are something that we all use on a daily basis, so we want to make sure that we maintain them correctly. When we look at building things, or we look at starting from the ground up, so a little bit on the soil side first, some characteristics we want to have. We want to make sure we have a high load-bearing capacity. We want good stability. We want lower water permeability. We have those 3 things, we got something that we can build on. We also want to make sure they're extremely level. The more level that we can make the bottom, the easier it is to make the surface level. Grading curve, depending on the type of materials, where you're at, what we have, we're going to look at different ways of compacting them, maybe with different size equipment. What layer thickness are we putting them in? Do I have the right machine? We need to look at all that information. When we look on the asphalt side, the different mix types. My territory is US and Canada, so I get to go around and see an awful lot of things, and there's a lot of different mix types that are out there that are just mind-boggling. We have different gradations. We have coarse, we have fine, we have open graded, we got FMAs, we got a lot of different things that we look at. The different binders that we're using, polymer modified, rubber modified, warm mix, other additives. We also got to look at the environment because asphalt is time and temperature sensitive. And when we talk about temperature, we got to talk about 3 temperatures: the base, the mix, and the air. One of those we can control. That's the mix. The other 2 are up to Mother Nature, but we can make adjustments based on those other 2 from morning, noon, and night. Coarse thickness. If we have variable coarse thickness, we're going to have variable compaction effort. So that's why the bottom layers need to be just as smooth as what the top is, so that we can maintain consistent thickness to get consistent compaction. When we look at the compaction system, it's really made up of 2 systems. One is just static, which is just the natural weight of the machine. The other one is dynamic, and we can split the dynamic into 2 different mechanical means: vibration or oscillation. Because now we're using more fractionated materials, we need more more force to break that resistance between the aggregates to get the final compaction we're looking for. Why is it important? We don't want things to fall apart, but it's important to start from the bottom up. If I don't have a good foundation to build on, asphalt is a flexible material, and it will flex, and it will crack, and it will break. So we want to improve that material stability. We want to minimize permanent deformation or rutting. We want to improve fatigue resistance and cracking, because if we start getting moisture inside these crack areas like this, when traffic goes over top of them, creates a hydraulic pressure and either forces the water into the base and loosens it up, and now we got an unstable material. If it forces the water out, it's going to take the fines with it, which has all the oil that holds things together, and it's just going to be the large stones and things are going to ravel apart. So we want to make sure we can do that. We also want to make sure we got correct bonding in between layers that help us reduce any kind of potholes. So physically, when you're rolling, you can actually identify maybe some of these things based on what we're doing. If we look at rutting is usually caused typically by 3 things. 1, we're over compacting. Most mix designs for highway or interstates are around 3.5 to 4% air voids. We still need to have some air voids in there to let it expand and contract, but we want the right kind of gradation and compaction effort to get that sustainability for the aggregate interlocking to support the traffic loads. So if we overcompact and we get less than the void content we're looking for, oil doesn't have any resistance or stability as far as retaining any kind of strength. So it's going to flow out from underneath where they are and create ruts. If we undercompact and we don't get enough compaction, traffic's going to do that compacting for us. Where that becomes a problem is when it rains and they fill up with water, now we're going to have a hydroplaning. So it's not a very safe thing. If it freezes, now we're going to have an ice skating rink. That's even worse. The last one we need to look at is just the mix. Maybe we have something wrong with the mix. We have our dust to asphalt ratio is wrong. Maybe something went wrong at the plant, even though nothing ever goes wrong with the plant. We missed a material, it's going through, something on that order. We look at settlements. Again, asphalt's a flexible material. We got something underneath there that's not compacted correctly, and it starts moving, we're going to have issues. We get water inside that base material, it loosens up. Again, we're going to have material that we can't build on top of. Binder enrich, or I call them fat spots. Too high AC content in the mix. Too much tack coat, and tack coat is another whole presentation. I think there's one on that this afternoon. But tack coat is very important when it comes to bonding the layers together. Incorrect use of dynamic compaction. Overusing vibration when we don't need to on too hot a material will actually draw that oil to the surface. Very similar like you have in soils. You vibrate too much and there's too much moisture in there, it'll pull the moisture to the surface. Pneumatic tire rollers, the only time I've seen this happen is if it's too heavy of a roller and it's on too hot of a mat and it's a thin lift and we got too much tack. I haven't seen rubber tire rollers do a lot of this, but sometimes it does. Like I said, overcompacting, mix is just too hot. Not too often do I see mix come out too hot, but if it does happen and we get on it too soon, a lot of times it'll start bringing up some fat spots. Outbreaks, faulty mix formula. Anybody talk about segregation? If we have segregated spots, a very coarse area, and we start vibrating on just rock material, we start breaking that rock, we lose our bond, things are going to start breaking apart. We have too much, or we do it on too cold a material because typically there's about 175 degrees is where we want to stop using vibration. That's been kind of the industry standard where we want to stop using vibration. That'll vary depending on the type of mix you're using and the thickness that you're in. Insufficient bond between layers. How many have seen cornrows for tack coats? Yeah, everybody thinks that's a great idea. That's the worst thing you can do. That helps promote this. Tack coat needs to be a nice even sheen across that material we're putting over top of it. Longitudinal transverse cracks could be the beginning of a settlement. Might be able to start some frost damage. Incorrect made seams, and when I talk about incorrectly made seams, it's really more of a temperature difference of what's compacted and uncompacted to where the machine, the roller, is going to want to push what's uncompacted away from what's compacted. And we're going to tear that mat, and we're not going to get it put back together. Fatigue, the start of maybe some soft spots underneath. Low temperature behavior, this is more of the tender mixes. A couple things cause tender mixes. The biggest thing is not getting the moisture out at the plant. If we got moisture still in that rock and we coat it with oil, that rock is hot, it wants to get rid of that water. Well, when it's trying to get outside of the rock, it gets trapped between the oil and the rock and creates this slip plane. And until that moisture gets evaporated outside, then it'll start bonding together. The other thing, it might be just our dust to asphalt ratio is a little off. We got too much dust in there, things are flowing around, it's moving around way too much. The other thing is just maybe too much dynamic compaction, maybe turning too sharp with the roller, starting too early on the material, too heavy of a roller. There's a lot of things we got to consider. Not everything is the roller's fault. We have to look at the paver. We talk about the screed settings, the toe points, where they're set at, making sure that we put a string line on the screed, make sure it's pulling evenly. A mix temperature, we talked about temperature of the mix. If I fluctuate the temperature of the mix, I'm going to fluctuate that head of material in front of the screed. That screed's going to be doing this all day. So we want to make sure we make that right. Uneven structure, we have uneven structure down below. We can pave it and make it look smooth, but when we roll it, it's going to roll right back to what we had underneath. Wrong sensors on the paver or the sensors on the paver not set up correctly. Understanding how to set up them correctly is key. Insufficient pre-compaction of the screed. We'll talk about this in a little bit, but every screed that's manufactured has vibration on it. And there's a lot of people that don't use it, but there's a huge advantage if you understand how to use it on what it can do for you. Variable speed of the paver, we always talk about consistent speed of the paver. We always want to make sure we don't want to speed up, slow down, stop. We don't want to be waiting for 20 minutes for trucks. In a perfect world, we all would like to pave continuously, but sometimes that doesn't happen. There are some things we need to look at on the roller side. When we speed up with our rollers too fast, we create too big of a bow wave in front, and we end up having bigger bumps at the end. Hard to get those out. The biggest thing that causes problems, though, is when we relate to frequency and speed and a thing called impact spacing. And impact spacing, we'll talk a little bit more how important that is to get compaction and rideability. Now, there are some things that we can do that are outside of what we can see, but I wouldn't recommend this way of getting rid of bumps. Take a 5-gallon can of gas, dump it on the bump, light it on fire, and then blade it off. Now, I show this mainly because if you look, this job, there's no one out there. There's no traffic control. We're out in the middle of nowhere. There should be no reason why we have a bump coming off of a cold joint. Absolutely none. We actually have other machines that'll do a better job in removing that bump. It's called a mill. So whose job is it for compaction? It's everyone's. Everyone needs to pay attention. It's a team effort. I always say the roller operator should understand how the paver works. Paver operator should understand how the roller works. It's a team effort. We need to do this together. So what is compaction? It's really just a manipulation of particles to get down to a material that's stable that we can build on. If we're looking on the soil side, when we start compacting, we create friction. When we create friction, we got to put some kind of a lubricant in there to reduce that. That lubricant is moisture, water. How many have heard of a proctor before? Okay, everybody understands. How we do that is we take a certain sample size and we add different moisture contents to it and try to compact it into a certain volume. If we don't have enough moisture, we get some pre-interlocking with the aggregates and a lot of voids. It's not stable to build on, not something we're going to work with. If it's too much moisture, we can't compact water, and all that moisture is going to come to the surface, and when it dries out, we're going to be back at this state again. When we have the optimal moisture content, we got the right amount of lubricant, we get all those particles matched up to where they need to be. Now we got something stable that we can build on, and we're reducing any kind of moisture penetration back into that. On the asphalt side, a little bit different. I mentioned before, we need to have some kind of air void content in there to move. It's a flexible material, but we want to have the structure there to support the traffic loads that are out there on the roadways. Do the same thing as far as mix design, finding out what is the optimum AC content. We're either going to use a Marshall mix design or a super pave, and we're going to have different samples with different AC contents, and we're going to find out which one has the 4% air voids we're looking for, and then that's the AC content we're looking for. That's the JMF, job mix formula. That's the material that goes to the plant, goes through the plant, back out to on the trucks, into the paver, and on the road. How do we measure it? On site, we can measure it either with some kind of a nuclear device or non-nuclear device to get an idea of what kind of compaction effort we're achieving with the rollers. It's not going to be exact, but at least we can set up some kind of a growth curve to get some kind of anticipation of what our rolling pattern should be. If we're going to check it exactly what we're going to do, we're going to go out and take a core, bring it back to the lab, test it, and find out what kind of air void content we have in there. 4 elements of compaction we look at. We look at static weight. Impacts can be tied into dynamics because it's a mechanical means. And dynamics, I mentioned before, is vibration and oscillation. And then we have kneading, which is our pneumatic tire rollers, but we can also throw oscillation in there because it's like a steel drum kneading effect on how that works. Static wheel rollers, the old ones, steel 3-drum. Years ago, the mixes that we had a lot of marbles in them. They were pretty easy to compact. We didn't start bringing vibration in until maybe the early 70s because we had a lot of round material. It was easy to compact with these kind of machines because it would compact from the top down and it was real heavy. Rubber tire rollers, great compaction effort on uneven surfaces. It helps bring the fines up to the surface. It starts compacting from the top down. Once it gets compaction down below, it needs that material up to the surface, pulling the fines and sealing it off so that we don't have any moisture get back in there. The key to rubber tire rollers, though, is air pressure. We want to make sure we have the proper air pressure in those tires so that our contact area with the mat is even, so we get the proper kneading effect in between the tires side to side and front to back. If we have too much air in the tires or too light of a roller for the pressure we have a knifing effect. And we're going to move the material too much and we're not going to get it compacted. Now visually there's one way you can tell this. If you look on the tire in the center, it's going to be nice and shiny. On the outside, it's going to be dull. On the other side, if we don't have enough air in the tire or too heavy of a roller for the pressure we're using, that material is going to want to cup underneath the tire. There's two ways you can see that pretty quick. First one is you'll see it on the mat looking like you got a flat tire. Scuffs it all up and it looks terrible. The other one is if you look at the tire, the outside edges are shiny and the center is dull or is going to start picking up some material. So being consistent with all air pressure in those tires is critical. Every tire manufacturer has a tire pressure chart. They're all different. All tires, they might be the same size, but they're going to have different ratings. Michelin tires are radials, Dunlops are not, so they're going to have a different tire chart. If you replace a tire on a rubber tire roller, make sure it's the same size and same manufacturer. Don't put a Dunlop with a bunch of Michelins. It's going to look like you got a flat tires out there. So when we look at vibration, vibration is going to help break that bond in between that aggregate interlocking. And what this shows, this is going to simulate what the weight is doing inside of a roller drum. It's cut off here, and it's going to, when you turn it on, it starts to vibrate. Once that touches the side of the glass, it breaks that tension between the particles to give you that additional compaction. Because we have more fractionated material, we need more than just static weight to get that compaction effort. So that's why we've gone into vibration. This one here just shows the example of the difference between an oscillation drum and a vibration drum. Vibration is a very aggressive compaction effort because 50% of the time the drum's in the air, the other 50's on the ground, creates a seismic activity that could be detrimental to surrounding buildings or lower substructures. Oscillation has the weights on the offset and they're 180 degrees off. The weight of the machine is always on the material. The drum is moving forward and backwards as it's rotating. So it's a very fast movement forward and backwards as it's rotating. But we don't get that seismic activity because the machine never leaves the ground. So static weight, just the weight of the machine going over the material. Vibration, 50% of the time it's in the air, the other 50 on the ground, creates a seismic activity. Very aggressive in most cases, but not needed in all cases. Oscillation, I kind of call oscillation a get out of jail free card because when you can't vibrate, you can always oscillate. Direct vibratory, this is more what BOMAG has as far as they call it like a vector directional. That will actually change the direction of its vibration based on the feedback it has on the roller itself. Why is oscillation important? Not all the particles are lined vertically. Some are on an angle, some are flat. So we need to move that material in a different direction other than just using vibration or static weight vertically. So oscillation can actually help in a lot of cases depending on the type of mix. It will work even better than vibration in some cases. Roller trains. Roller trains is basically anything that follows a paver. It could be one roller, could be 3 rollers, could be 10 rollers. It doesn't matter. This example I'm going to spend a little time on. And it's an example of, most cases, it's a design of 92 to 96% is what I'm looking for in the field. I'm going to first start with this machine right here, the screed. We want to make sure we use the vibratories on the screed because a few things. One, we're at the most optimum point where all our temperature is, so we have a much better chance of getting compaction when we have all the temperature. When we use vibration, it helps the flow of material go underneath the screed, where we can maybe even lower the angle of attack a little bit and reduce the wear on the screed. Everybody don't like using the vibrators on the screed, but a lot of people don't set them up correctly. A good friend of mine told me, he says, listen, take a quarter, put it on the frame, and he says if you turn the vibes on and it's not moving, they're not high enough. If the quarter just starts dancing a little bit, then you got it set up right. If it bounces all over, it's too high. Now that will change depending on the type of mix, the temperature of the mix, and the lift thickness. So it will have to be something to adjust. But if I can gain 1 to 2% more density using vibration on a screed, that's 1 to 2% less I have to worry about the roller train trying to do. And that could be the difference between getting bonus or not. Now the breakdown roller here, if 92 is my minimum, I want to achieve as much as I can with that roller as possible. I don't want to achieve it all. If I try to achieve it all, they'll probably never see the back of the paver. And then the mix starts cooling down and we have more problems. If I can achieve 90 to 91% with my breakdown roller, I'm pretty happy with that because I probably still have enough temperature in there. I can maybe use my secondary roller with vibration. And then it's going to gain maybe 1, 2%. Finish roller, maybe 0.5% to 1%, run either in static or in oscillation mode. I also have distances here for each of the passes. I always tell people I don't want them too long, I don't want them too short. If they're too long, one side of the road cools down much more than the side I just compacted, and we're going to struggle getting density on the one side. If they're too short, I'm not as efficient. I got too many crossover areas, and if I'm not vibrating through my cross areas, I'm only running static, I am not going to get density in my crossover areas, and we're probably going to see it in rideability as well. So it's very important to understand the distance that we want to run those. Roller trains are flexible. They can be a lot of different machines in different positions. This is probably typically what I see in most cases, with a rubber tire roller in the middle. There are some states that put the rubber tire up front. There are some that require it as a finish roller. I don't know why, but they do. But it's very important to make sure we understand which rollers we have and how to use them correctly. Different types of rollers. We've got the old static rollers, just heavy rollers. A lot of times we're just using them for smoothness. Our finish rollers, maybe pinching some joints. They come in different shapes, different sizes. Older ones like this, some of them are still around. Typically we see more of the 3-wheel rollers. We see a lot of these on like SMA mixes where a lot of times they won't allow vibration. They still want the heavy static 3-wheel rollers on there. Rubber tire rollers, we talked a little bit about there. Another key thing to remember about rubber tire rollers is heat. We want to make sure we maintain that heat in the tires so we reduce the amount of pickup and reduce the amount of additives that we're going to have to put on the tires. The more additive you put on the tires, the cooler you get, the more stuff you end up picking up. Rubber tires also do not like polymer or rubberized mixes. A lot of times what we see is we're going to have to back the roller off probably about 20 degrees from where we normally run it just to reduce the amount of pickup. The problem with that is if you have a lighter rubber tire roller and reduced temperature, we're not going to get the compaction or kneading effect that we think. So you really need a heavier roller if you're looking at going out on a polymer or rubber modified mixes. Rubber tires are nice because they balance how they compact on uneven surfaces, especially on soils. But anything, especially like joints and stuff like that, we can get a lot even pressure and even compaction effort with the tires on a rubber tire. All manufacturers have rubber tire rollers that have offsets front and rear, so you get the kneading effect in between the tires, and you also get the kneading effect front and back. We talk about release agents. Years ago, the best release agent was diesel fuel. The problem with diesel fuel is put it on the tires, softens up the rubber. Anything you run over gets stuck in the tire. you hit the corner of a catch basin or a water main, chunks out the tires. There's a lot of different release agents out there. I just say find something that works best. There's a lot out there. Combination rollers. Combination rollers are becoming more and more popular, especially with municipalities, small contractors doing parking lots and so forth, where you have the vibration drum up front and the rubber tires in the back. They're great for steep angles because you got a little bit more traction with the tires. Nice thing is we can actually run them in reverse, put the rubber tires up front and finish with the steel. So you got two rollers in one. A lot of municipalities like that. They can only have to run one roller. Most common we see is a dual vibratory roller where you have vibration front and rear. The nice thing about the newer machines is we have individual controls on the front and rear drums. So there's a lot of different settings that we can do based on what we're trying to compact. Get them in the large rollers, small rollers. Oscillation rollers, another one. Can use in any position, breakdown, intermediate, and finish. It shines probably better in the intermediate and finish side, but in certain mixes it really shines in the breakdown position. You got an OGFC or an SMA mix, works really good because sometimes some states won't let you vibrate at all, but they will let you oscillate on those types of mixes. This section here applies to any roller, like I mentioned before. This is kind of the principles of compaction that we're going to talk about. We're going to talk about amplitude, we'll talk about frequency. Sometimes people get confused what those two are, we'll explain that. We'll talk about static weight again. Centrifugal force, the biggest misconception people have in centrifugal force is they think the more centrifugal force I have, the better compaction I'm going to get. That's not necessarily true. It's understanding how to control that centrifugal force for what you're trying to do. And every manufacturer has a little bit different how they set up the amplitude and frequency. We have two amplitudes with a variable frequency. Other manufacturers have multiple amplitudes, but set frequencies. So finding the setting that works best for what you're trying to do and control that centrifugal force is key. Roller speed, when we talk about roller speed, we tie it into a frequency. Roller speed and frequency goes into a thing called impact spacing, which is very important. Drum diameter, a lot of people don't think about drum diameter, but it does have an effect, especially on thicker mixes, what we can do. Activation controls, I mentioned that, individual front and rear. Drum, water, and scrapers. Two most important things on an asphalt roller is the water system and the scrapers. The two most neglected things on an asphalt roller is the water system and the scrapers. The two easiest things to maintain on an asphalt roller is the water system and the scrapers. And then drum offset. A lot of manufacturers are going to drum offsets. There's great little advantages there. We have it standard on all our large machines. It's a mechanical offset on our smaller ones, but there are a lot of advantages for it, and we'll show you what those are. So when we talk about amplitude, we're talking about how hard I'm going to hit something, the size of the hammer I'm going to use. If I have a small hammer, I'm going to have a little force, not going to have as much centrifugal force. If I have a sledgehammer, I'm going to have a lot of force. That's the amplitude. Amplitude is the size of the hammer I'm going to use. Frequency is how fast can I spin that hammer. Well, if I got a small hammer, I can swing it real fast. If I got a big sledgehammer, I can't swing it as fast. So the smaller hammer, higher frequency, larger hammer, lower frequency. All manufacturers in some states require to have some kind of a startup chart or setting chart for the operator to preset the machine before they get on the mat. So we put together a little chart that says if you got a certain size machine, certain lift thickness, this is what we recommend setting up the roller at to start with. You'll need to finalize that through some kind of a growth curve to do that. But all manufacturers have some kind of a chart like this. So we talked about roller speed and frequency. This example here, we have a roller traveling at 3 miles per hour. We have the frequency set up at 3,200 VPM. Every time that drum hits the ground, there's a space in between there. This happens to be 1 inch. So in 12 inches, I get 12 impacts. 12 impacts per foot. That's a key number. I always tell people if I can maintain between 12 and 16 impacts per foot, I don't care whose roller you have, what size roller you have, you should be able to achieve the compaction and rideability you need if we stay within the certain temperature range we're trying to achieve. Same roller, same frequency, only we speed up to 4 miles per hour. Now instead of having 12 impacts per foot here, we're down to 9 impacts per foot. We start dropping below 10 impacts per foot. We start leapfrogging too much, we're going to increase our number of passes, and if you're doing any kind of smoothness test, it's going to start recording as a chatter in your IRIs. So we don't want to go any faster than that. This just kind of gives an example of where standard vibratory rollers at 3000 VPM are and high frequency rollers are when we look at the minimum of 12 impacts per foot. If you look at the 3000, 12 impacts per foot, we're about 2.8 miles per hour. Well, at 4000, at 12 impacts per foot, I'm about 3.8. So with a high frequency roller, I can still maintain the same impact spacing, but I can go faster. So now I got a better chance of keeping up with the paver, maybe go a little bit faster with the paver, get more production. We have these magnetic charts that do the same thing. We put them on a lot of rollers, impact spacing up here, frequency down here, and our speed is in the center. So at 3000 VPM, 2.8 miles per hour, 12 impacts per foot. 4000 VPM, 3.8, 12 impacts per foot. Doesn't matter what roller it goes on, it's just tying speed and frequency together to just calculate your impact spacing. So these orange ones look really good on yellow machines. We don't want to see this, whether it be we're vibrating on too cold a material to build a chatter and start crushing rock, or we're spacing too far and having issues like that. This is an example of a project I was called on down in Georgia where a customer was using one of our oscillation rollers, and they said every time they used our oscillation roller as a finish roller, the road had a hum in it. Never heard of a singing road, but okay, we'll go down and check it out. Everything was okay with the machine. We took a drive out to the road. As we're driving out there, you could hear the hum in the road. We get out there, they were actually paving the shoulder over here. This is the main line. The breakdown roller was an Ingersoll Rand DD130, comes off with the vibration still on the mat. That's a 1 foot ruler there. How many impacts do you see? 4. What was the minimum number I said? 12? So what I can do in 1 pass, they have to try to do in 3. There's a lot of times I get on jobs, I said, listen, if you slow down, you'll go faster. And people look at me like I got 3 heads. What do you mean if I slow down, I'll go faster? Well, if I can cover in 1 pass and get what they're trying to do in 3, I'll be faster than them all day long. So the paver was running 75 feet a minute, had 2 rollers, the 130 and a DD24. I stopped the roller operator, I said, how fast are you going? He said, I don't know. He said, I'm just trying to keep up to the paver. I said, well, what's your dial setting for your amplitude and your drums? He said, I don't know, the numbers are all out, we never change it anyway. I said, what's your frequency? He says, I don't know. He says, the button don't work. He says, it just runs. And I'm like, okay, so you have no idea how fast you're running, what your amplitude is or your frequency. But they're looking at blaming the oscillation as causing it. Well, what was causing is because the spacing was so far apart, oscillation wasn't taking the bumps out, it was accentuating them even more. So 4 impacts per foot creates a bad ride. I don't know if you can see the ripples in the road. That was 20 miles of 4-lane highway that was almost remove and replace. Found out that the paving foreman was getting paid 50 cents for every ton. He was running mainline at 125 feet a minute. Now, if anybody knows anything about paving, you get over 65 feet a minute, you outrun your electronics. Might as well just take them off. But at 125 feet a minute, he would run out all his trucks and stop and wait for 45. Get the trucks back, run out 125 feet a minute, sit and wait again. They changed foremen on the jobs. They reduced their forward speed to 40 feet a minute, never stopped. They got the same amount of tonnage at the end of the day, and they were getting ride bonuses. versus trying to remove and replace. So speed is a killer when it comes to impact spacing and compaction. So like I mentioned with the high frequency rollers, if we want to go a little bit faster, we have a better chance of keeping up to the paver. We can still maintain that impact spacing at a little bit higher rate. The nice thing is if we're on thinner lifts, we can reduce that frequency to reduce the compaction effort without breaking rock and still getting compaction. Now we talk about drum diameter. When we talk about drum diameter, it's angle of attack. With a smaller drum, our angle of attack is much greater. So we have a tendency to push more material with that drum, especially if it's thicker. You get in 3 or 4 inch lifts and it's a small drum, you're going to push more material, create a bigger bump at the end. You might even see some hairline cracks here. So with a larger diameter drum, our angle of attack is less, so more material is going underneath the drum, getting compacted and being pushed out in front of it. So now we have less of a bump when we come to stop, and we're not going to see any kind of hairline cracks back here. So looking at drum diameter is a big thing. Water system. Every manufacturer has either one spray bar or several spray bars, but they need to be monitored, and we also have a water management system on them. Because in some locations, water is a high commodity. You're out in some areas where you don't get a lot of water, you got to manage it. I always tell people you only need enough water on the drums to keep from picking anything up. Anything more is a waste. I don't want to see Niagara Falls coming off those scrapers down the front of the drum. I don't want to see water spraying out the side of the scrapers. That's too much water. So how our system works, we have 5 different settings. Up at setting 5, every time you move that machine, it's spraying water. You go down to number 4, it's on 1, off 1. Now I've saved, by pressing at 1, I've saved 50% of my water. I go down to 3, it's on 1, off 2. I've just saved 2/3 of my water. So having a water management system is very key, and understanding how to use it is key. We have 2 different pumps. One pump runs both spray bars at the same time. I always tell people too, I said on even days, use pump 2, odd days, use pump 1. The scraper system. Every roller has a dual scraper system. They have a dual function. If I'm going from left to right, this upper scraper is my water trough. The bottom one is scraping anything off the drum. The top one, water sprays on the drum, hits the scraper, spreads a thin film of water on the drum before it hits the pavement. The bottom one scrapes anything off the drum that you're going to pick up. You might pick up some small stuff. You just want to make sure it's not picking anything and sticking to the drum. When I go in the other direction from right to left, the roles reverse. This one becomes my water trough. That one becomes my scraper. A couple things I always tell people. I said, scrapers are spring-loaded. If the springs are locked up, you're not going to get the proper tension of that scraper on the drum to give you that thin film of water. So I tell operators, I said, carry around a can of WD-40 and spray all those springs down. When I let that scraper go on the drum, it should pop on the drum. I want to hear it pop. If I let go and it doesn't even hit the drum, and it's not touching the drum, I'm going to use more water. Make sure the frames are not bent. Because if I only have 3 inches of the scraper that's not touching the drum, you're going to use a lot of water just because of that. So we want to make sure the frames are in good shape. The scrapers are in good shape. Every manufacturer has the ability that you can pull them off the drum. So if you're traveling down the road, you're not wearing them out prematurely. If you're running 7 miles an hour down the road with the scrapers on, that creates a lot of heat. And I can always tell when people do that because I look at the scrapers, and if they got eyelashes on them, I know they're not taking them off the drum when they're traveling down the road. If you forget, spray it with water a little bit, at least cool it down. Drum offset, great for pinching joints. We'll explain that in a little bit. If you have a mix that has a tendency to leave a lot of marks, because most rollers, you got a dual cutting edge with both drums. If you offset them, you only have a single edge. One drum's always covering up the other drum's edge. So it'll help reduce some of that marking. Moving away from curbs, if I'm going from right to left, I only need to concentrate on my front drum. My rear drum, when I pull off that curb, is not going to take anything away from that new curb, especially if you got new curb. Cul-de-sac, same thing. Whether you're inside or outside, just make sure the front drum's on it, rear drum's away. Now when you back up, just got to turn the drums back the other way. External factors affecting compaction. Nobody paves in the rain, right? Sometimes we get caught in the rain, but a lot of times the first person to blame is the last person that's on the job. That happens to be the roller operator. But there are some things we can't control. There are some things, some blemishes we can fix from the paver, some things we can't. Mix design, if the mix changes, a lot of times the good operators will know something's changed. Whether it be the AC content, more fines, less fines, real good operators will be able to tell by the sound of the machine and the feel of the machine. Mix temperature, again, this is the only thing we can control. If we start getting fluctuating mix temperatures, we don't want to keep jumping around trying to change our rolling pattern because the mix temperature is changing. Everything needs to stay consistent. Paver issues. Talk a little bit about that, but if our screed is not set up properly, there are some things that we can't fix with the roller that the screed actually puts in there. Understanding the equipment, the proper setup is key. Operator issues. This is one I always say, I want to make sure when I go on a job site and I'm showing someone how to use a machine, before I leave, I want them to understand full functionality of that machine like I would, and the adjustments they need to make and why or how they're making them. Ambient temperature, like I said, that'll change from morning, noon, and night, but we can adjust for that because we know it's going to change. Base conditions, what are we compacting over top of? Is it milled asphalt? Is it concrete? Is it gravel? Is it patchwork? The roller will react differently to different materials that you're compacting over top of. So you might have to establish a separate rolling pattern depending on what you're rolling over top of. Asphalt is nothing more than liquid AC and different combinations of rock, sand, and filler. They come in different shapes, different sizes, different textures, flat and elongated, rigid, cubical, a lot of different things. Absorption's different. Liquid AC, polymer modified, rubber modified, warm mix additives. Stabilizers on certain types of mixes. You got fillers of crumb rubber, maybe some fibers that we need to put in there. We look at a lot of different things. The old conventional Marshall mix design, the old rule of thumb was if I had a 1/2 inch rock nominal size, if I double it, I should be able to get compaction. That was fine when we just had static rollers. But now we're using in Super Pave, that same model is looking at 3 to 4 times the thickness of that nominal maximum size so that when we do vibrate, we got a little cushion, but we're going to build a structure that's going to support the traffic without breaking rock. Because the last thing we want to do is break rock, especially on the joints. I always tell people, I said, I can always tell which side of the road was paved last by the side of the joint that fails first. Because we have a tendency to vibrate too much on the cold side, and that's the side that breaks up. Some people have seen this before. This is a gradation curve. We look at the different types of mixes that are out there. I call this one kind of just a lunchbox mix. This is what plants usually have that are just for outside sales. If you want to do driveways or parking lots, this is just a regular mix that they have at the plant. Could be coarse, could be fine, depending on what is available for materials at the time. We have single size material with a very low AC content. Did a project up in Rockford, Illinois at the Rockford Airport. We did 2 4-inch lifts, 3/4 inch rock, 2.2% AC. Didn't do any densities, but at 8 inches, while we tested it, we had the fire truck come out, spray down. If it drained, great. If it puddled anywhere, we had to remove and replace it. Then they put 12 inches of concrete over top of it. So good drainage base. Open graded friction course, we can use this as a great drainage base as well too. A lot of places are looking at this as a surface mix to reduce noise and reduce water splashing when you have rain. High void content's usually around 15%, but they're also looking, like I said, for a noise reduction, so they don't have to build those barrier walls on the side of the highways to reduce noise. All the noise goes into the mix, doesn't get reflected out. This one here, our SMAs are gap graded. These are our expensive mixes. We got a lot of rock on rock content, nothing in the middle, and a lot of fines. Well, by doing so, we got to put some extra stuff in it. It's very rut resistant because of the structure of the aggregates in there. But it's very expensive because we're usually using some kind of a polymer modified or rubber modified asphalt with it, and putting some kind of fibers in there to help reduce that drain down or puddling of the oil. So with all these different gradations, I tell people you're not going to compact everything the same way. And how do we know we got compaction? Well, hopefully someone's out there checking with a density gauge to see what you're getting. If you don't have one, I always tell the operators, keep a log. If you do have someone come out checking densities, record your type of roller you use, your speed, your impact spacing, your amplitude, your frequency, temperature of the mix, type of mix, what we're placing it over top of. Keep a record so if you go to another job and don't have anybody there to test, at least you can preset your roller and give you a better chance of getting compaction. Temperature is our friend when it comes to asphalt. When it's hot, it's easier to compact, easier to do handwork, less segregation. When things start cooling down, we have a harder chance of getting compaction. We do handwork, we start segregating the material, we get some surface segregation, and all those large stones are not going to compact, and we're going to start raveling things up. Some places don't have control on the type of equipment they're going to have on a job site, but matching the equipment for what we're trying to do is a huge part of the success. This example here is just kind of a cul-de-sac area in a residential area, probably laying an inch thick of material. I don't want to have an 84-inch, 14-ton roller behind my paver. I'm going to make a mess of that. I want to have a big enough roller to get me the compaction, but a small enough roller to be agile enough to get in and around without tearing the mat, in and out of the driveways to get proper compaction. This is something that I use when I go out on projects just to observe what they're doing. And what this is just a temperature chart where we can set up some information. We got the lift thickness, we have delivery temperature, we have surface temperature that we're placing on it, we got outside temperature. We can put some information in here, and when we do a calculation, we have this pretty color chart. The green one is the back of the screed. The red one here is at 175, the industry standard. We can move that up or down if we want to. But anything underneath this curve and inside here is my time available to get compaction before I drop below that temperature 175 degrees where I got to shut my vibration on. Well, that's telling me I got 43 minutes to do that. I got all day. But how often are we doing 3 inches of paving? Look what happens when I drop down to 1.5 inches and I recalculate. That 43 minutes went down to 14. Now my window of opportunity is very narrow. And how is the paver going faster paving 3 inches, or is he going faster paving 1.5 inches? It's going faster at 1.5 inches, and that paver is going to be further out, and I got less time to compact. So a lot of times when I look at this, I make suggestions instead of using the rollers front to back to try to cover everything, move them in tandem, echelon. So now you have one roller covering one side of the pavement, the other roller covering the other side. You'll increase your compaction. You might even eliminate having 2 more rollers behind you. You just have one to finish things up because you're going to get most all your compaction with those 2 rollers running in tandem. Now, some of the other problems I come across is foremen will say, we can't do that. And I'm like, why not? It's like our guys will run into each other. I'm like, well, I can't train them on that, but we can work with it. But a great tool. What's nice about this is you can put different factors in for the morning, noon, and night and see what kind of changes you see based on ambient temperatures or base temperatures. You can print this off and put it in a file, record it for jobs, however you want to do it. I use it just for observing when I'm out there to see what I need to do next. This is also free. If you Google it, PaveCool, you can actually put it on your phone. I have this one and I have this multi-cool one This one, Multi-Cool, is actually in the App Store, so you can download it and put it on your phone. I don't like it as well, but I like the other one better. But they work great. It's a great tool to have. So we saw this picture before with densities. Now we're going to look at the same thing with temperature ranges. These temperature ranges will vary depending on the type of mix. This is probably just a standard mix. It's a good number to have. If I had a polymer modified, that upper limit is maybe 350, 360. If I have a warm mix, maybe it's 260, 270. But at least if I know my ranges to get all my passes in and stay consistent with that, I've got a better chance of getting density and I got a better chance of getting rideability. Cooling rate effect, we saw what matte lift thickness did for that cooling rate in my time to get compaction. Like I said, our ambient and base temperatures will change morning, noon, and night, but we can adapt to that. Our asphalt mix laydown temperature, that's the only thing we can control from the plant is that temperature. The other two are up to Mother Nature. Wind velocity, a small 5-mile-an-hour wind on a cool day and a thin lift will cool that mat super fast. So it does have a big effect on it. The other thing is, what are we paving over top of? What are my conditions? Do I have something like this that I can just get away with maybe mill and fill it? Or if it gets down into the base, I don't want to just mill and fill it because then it's like putting a Band-Aid on something that needs stitches. It's going to come back up. We definitely don't want to pave over something like this because remember, the paver pushes the truck don't pull the paver with what we're trying to do. Preparation is critical, so again, we can just mill it, or we got to do something different when we have this, whether it's remove and replace or stabilize it. But whatever we're going to do, we need to make sure it's smooth so that our surface is going to be smooth. If we're milling it, again, like I said, make it smooth. If we're reclaiming it, make it smooth. Some states are going to a very fine mill and fill. State of Florida does 3/4-inch mill and fills in a lot of places. They don't allow you to vibrate on anything. But if we have to mill a full lane width, we want to make sure our equipment is in good condition. Because when you only have 3/4 of an inch to work with, I got any high spots, I'm going to bridge on those and I'm not going to get the compaction I'm looking for. So we need to make sure we have very good, stable equipment for what we're trying to do. All right, 10 commandments of rolling. Roll as close as possible to the paver, but do not hit the paver. So many times I get on a job site, you see the roller guy want to creep up to the back of the paver. I always tell people the closest that roller needs to get to the paver is the length of the roller. I don't want them to slow down because if you're slowing down to creep up to behind the paver, as the paver is moving, you're losing time. And you're only running it static anyway. I want you to keep doing your same passes all the time. Now, if the paver stops and you want to get compaction up to the screed, that's a different thing. But as long as that paver is moving, I don't need to get that close. I want to be consistent with my passes. I always like to start compacting on the lower edge. All roads have some kind of a slope. A lot of people like pinching the joint first. I don't like doing that. I'm not saying it's right or wrong. I just don't like doing it because if I do the outside lane first, I am compacting and resisting anything to move out away from the joint. And then I'm going to work my way up to the joint. And when I compact that joint, by the time I'm ready to compact it, that hot mix has warmed up that cold joint. So when I do compact it, I get a better bond at the joint. So I want to push the material against gravity up towards the joint. Some people say, well, I got too much material there and it rolls over. That's just an adjustment with the joint matcher on the screed. Finding that fine-tuned adjustment. Only time I go joint first is if it's next to a hot mat. Then I want to go back down to the low side, still bring everything back up to the joint. Deactivate vibration before reversing. I throw that in there and people think, well, that's crazy, that's common sense. You'd be amazed how many times I get in jobs, people forget to shut the vibes off when they come to a stop and back up and wonder why they got a bump there. It does happen. Change roller speed gently. The older machines, you had control of the speed of the machine with the F&R lever. The newer machines now, all manufacturers will build in some kind of a coast factor. So if you're going forward and you slap it in reverse, it'll come to a slow stop and then back up on its own. Forward and backwards in the same track, just move over slightly. I don't want you to move a whole other lane over. Just going back and forth in the same track. Change tracks on the cold side or the beginning of your passes. Anytime we turn on a hot mat, we have a tendency to tear it. I have less chance of doing that at the beginning of my pass because it's a little cooler. Parallel tracks, side by side. Water the drums sufficiently. I only need enough water on there to keep from picking anything up. Never leave the roller on the hot mat. So many times I see when the paver stops, that breakdown roller's right behind the screed. If you're going to be behind the screed, at least stay on an angle. If you have any chance at all, get off on a cold mat. Or back up to where your beginning of your pass is and sit there. It's a little cooler, less chance of putting dimples in there. And let the other rollers go by and finish their rolling patterns. We also want to keep our eyes on the drums. Want to make sure we're watering them sufficiently. Make sure we're not picking anything up. We also want to make sure we're looking in front and back of the machine because we don't want to run anything over. It's all about being consistent. Because if we're not paying attention, we end up like this guy. So after finishing, we want to make sure we park the roller in a secure, out-of-the-way area. We don't want to end up like this. Most states now require you to be a minimum, I think, 500 feet off an enclosed or a closed roadway. Cones were set up about a foot off of the roadway. 17-year-old kid dropped his phone, hit the back of the roller, never knew what happened. Inspect the drums and scrapers. Spray the springs down with WD-40. Make sure they're off the drums if you're going to be traveling down the road. Inspect the water system, clean the filters. Every manufacturer has some kind of a filter system, and it's usually a multi-filter system. One in the tank, one in the filling tube, one in the tank, and then also each nozzle has filters as well too. We also have built-in antifreeze systems to where we can flush the system or fill the system with antifreeze on cold days so you don't have to worry about disassembling everything. Pick up and remove trash. Turn the battery switch off. Older machines, tier 3 and tier 4 interim, we could manually disconnect. The newer machines now, because we got the DEF fluid, when you shut the machine off, the pump runs from the DEF fluid to pull all that material through the lines back into the pump. If you disrupt that and it gets clogged, the machines are going to derate and you're going to have a machine that you can't use. And it creates a lot more problems after that. Some things that affect rolling pattern, just basic rolling techniques, our paver speed, number of passes, number of coverages. Number of passes is different than number of coverages. And then our joints and edges. Again, we don't want to stop on a hot mat and vibrate. We'll put bumps in there, we won't be able to get out. We also want them to at least overlap a minimum of 6 inches. If I don't overlap 6 inches, I'm going to create a tear area because that bow wave of material in front of the drum, we have a slight bow wave on the side of the drum, and if we don't overlap that, it's going to tear, and it's because it loosened up the material, and we're not going to be able to put it back together. Slow start and stops, like I said, that's usually designed and built into the machines. This is just a quick spreadsheet that helps manage the equipment that we're trying to use. Anything in gray we can change. We got the plant material, we got the trucking, the paver speed, and the roller. Down here, paver speed's 25 feet a minute, roller speed's 25.7. Everything matches up, we should be good to go. If I change one number here, from 3 to a 4, now all of a sudden my paver's outrunning my rollers. That's telling me I got too small of a roller for the job I want to do. I need to get a bigger roller. So just a little spreadsheet to help balance things out and figure out what it is we're trying to do. Always want to stop on an angle, whether it be at the paver or at the beginning of your pass. This is why. If I stop straight on behind the paver, I got compacted material and uncompacted material. When that temperature changes, I'm not going to be able to compact the uncompacted to the same level because of the resistance and the temperature. So when I try to come straight through there, I create a bump. But if I stop on an angle and I just come straight through there, I have a much better chance of getting that bump out. It's even better when you go in perpendicular to it to get it out. Rolling number of passes every time I go on job site, first thing I do is I ask the quality control manager and the operator, what is your definition of a roller pass? Because everybody's a little different. It's not the same. My idea of a roller pass is anytime I'm moving that roller in one direction, I'm creating density. That's pass one. If I come back in the same track, I'm creating density, that's pass two. There's a lot of places that call that one pass. So if I tell them, I said, I'd like to see a 5-pass pattern, and they start running 10 times, that could be a big problem. We're going to do this for consistency. Each roller is going to have its own growth curve or setup as far as passes go. We're going to be an odd number, because your odd number is going to catch you back up to the paver. So it'll be 3, 5, 7, 9 passes. If up and back is 1, it'll be a half pass. 1.5, 2.5, 3.5 passes. Number of coverages is a little bit different. Number of coverages is basically how many times will the width of my roller cover the mat that I'm paving. That example I showed, I went from 3 to 4. I went from 3 coverage passes to 4 coverage passes, meaning I had too small of a roller to cover what I needed to do to keep up in paving. Again, we're going to change on the cold side our tracks to get back up. This is one that I like to show people because the last pass where you're going to catch up to the paver, everybody says, well, I go down the middle. That's the worst place you can go for a couple of reasons. If I go down the middle, the outside edge of my drums are in the wheel path. We don't want to disrupt the wheel path by putting the drum edges on there. And if I get to the end, now I either got to turn up or I got to turn down. So now I'm turning on the mat on a hot mat, uncompacted mat. Chance to tear it. I don't care if they go top or bottom. I always say go to the bottom because if you're going to push everything up to the joint, you're at least getting the outside edge compacted. And a lot of times the outside edge is the first one that has density that's a little bit lower than closer to the joint. So give the outside edge an extra pass. Longitudinal joints. This is the way I prefer to do them. This is also the way the Asphalt Institute shows them as well. When we get up to the joint, we have both vibratory drums on. We stay in 4 to 6 inches off the mat or off the joint. Coming up to the paver, when we come back, we overlap that 4 to 6 inches, but we run it in static. Most people run it with vibration on. And when you run it with vibration on, this is what happens to the cold side of that joint. I compact the material down to the level where that cold joint is, but now when I get to the cold joint, all the force of that roller transfers to that cold side of the joint and to the outside edge of the drum. So now you're busting up the cold joint and you're creating a mark in the center of the mat with the outside edge. Oscillation, this is where it helps an awful lot. Same thing, 4 to 6 inches off, both drums, one on vibration, one oscillation. We get up to the paver, we come back, we overlap with both drums, but leave the oscillation drum on. Turn the front drum off in vibration, run it static. Now with an offset, it's even better. With an offset, I can have the front drum 4 to 6 inches off and the rear drum overlapping 4 to 6s running in oscillation. So now I can do it up and back and get better compaction at the joint without destroying the cold side. Because oscillation is not going to break things up because it doesn't transfer the force to the cold side. It gets down to the cold side, but now it still has temperature. It's going to manipulate and compact that material into the joint to give you a much tighter joint. Tech and sustainability. We talk about this. Do it right the first time. Get in, get out, stay out. A lot of times we have a tendency to do things more than once. Cost us more, reduce maintenance. We just want to make sure that we're going to get out there. Again, we're looking for density. We're looking for smoothness. That's going to give us pavement longevity, reduce maintenance. There's a lot of things that follow through with that. That's sustainability. If we can sustain our roadways for a longer lifespan, that's sustainable. If we got to go back in for half the life, that's not sustainable. You saw this slide before with what Tommy showed. EPDs are a big thing that the federal government's looking at. There's actually these different stations. The 3 stations we're looking at right now for EPDs have to do with at the quarry, the trucking to the plant, and the plant producing the mix. We're seeing that that's an awful lot. Next thing in stage is going to be our construction stuff. That's where we get tied in as manufacturers. What is that going to cost the customer out in the field as far as EPDs go? This is going to take some time to figure out. It's kind of a swag right now. No one really knows what the numbers are meaning, but it will affect a lot of customers in different areas depending on where you're getting your materials from and how you can be competitive if you're multi-state. So right now we're still working on these 3. They have no idea how they're going to tackle these. But their biggest thing is how they can figure it out from cradle to grave and back around again. So if you look at how things are broken down between the materials, transport, and plant, this is what the first 3 look like and what the biggest cost factors are when we look at just a typical plant. You look at a location, of 2 different plants, plant B and plant A. When you look at the transport and what the EPDs are, they basically balance out themselves. Some of the things we look at on rollers as far as technology to help reduce passes, reduce costs, reduce fuel usage. How many have heard of intelligent compaction? It's been out there for quite a while. A lot of states are really jumping on ship with it. Some haven't really adapted it yet. Minnesota is probably the largest leader of it. Every project that they use, they not only use intelligent compaction on every roller, but they also use thermal imaging cameras on their pavers. So they're way ahead. We have our HCQ navigation system. We also have WETOS HCQ, which we can actually see it live, whether it be on a phone or back in your office and what you want to do. All of the information from all intelligent compaction systems, whether it's ours or someone else's or other manufacturers, has to be tied into a software called VEDA. This is what the states are looking at to compare the results by, and they can break it down by lot, by sublot, however they want to do it, and this is how they're going to look at getting paid. We're updating our system. We've learned a lot from customers. We've learned a lot of what the state needs are to adapt the system to make it simpler, cheaper, easier to use. Tommy also mentioned about the operations center. There's an unbelievable amount of data that we can collect from our equipment. We can collect it in our operations center, and then there's other softwares out there. You see Haul Hub out there, you see Fleet Watcher, SOB. They're information that they're going to tie into a thing called MDMS, Material Data Management Systems, where we're monitoring the plant function, the trucking, the paver, the roller. All this information is going to be taken from the equipment, put into these softwares, and it's information that the state's going to be required by specification. So it's a lot of work on our end to work with each other and the software companies to make sure they get the proper data and we can get it into the information in a way they want to look at it. So summary, compaction, again, it starts from the bottom up. We want a good stable base material to start with. Proper density on the asphalt, we're only going to get that if we got a good compaction on the base. Different elements of compaction, static, impact, dynamic, and kneading. We want to make sure we get them right. Roller trains, they will vary. Everybody kind of knows what they're going to use in their area based on the material and a specification that's allowed. The different roller types, great in certain locations. Like I said, combination rollers are being more popular with municipalities because it's 2-in-1. We're even seeing some contractors doing some unique things with them out on the highway jobs, especially if it's not polymer or modified. Roller design specs, this is what is tied into all rollers. And the impact spacing that we talk about is key. Speed's a killer. 12 to 16 impacts per foot, I should be able to achieve what I'm looking for. Tech and sustainability, a constant role that all manufacturers are dealing with based on what the needs of the FHWA and the government's looking for. But it is a definitely work in progress that we're working on pretty substantially. External factors, beware of your conditions. What are we doing? Are we paving in the rain? Is it, what are we paving over top of? Understanding how to set things up correctly. And then when we talk about temperature, there's 3 temperatures: base, mix, and air. The one we can control, that's the mix. That's the only one. If that fluctuates, we have no control, because we're not want to change anything else. We just want to be consistent in what we're doing. And with that, I don't have any more. Boy, am I right on time? Holy, that never happens. But if any questions? Any comments? I'll be here until after lunch, and then I got to head out, but feel free to come up and ask me any questions if you like. Appreciate you taking your time, and enjoy the rest of the conference.